Hello everyone. Today we're covering 13-1, which is the chemistry of Earth's atmosphere. The objectives are develop a model to explain what happens when the sun's energy absorbed by the Earth's surface, converted into infrared radiation, describe how the greenhouse gases differ from nitrogen and oxygen. Describe three ways molecules oscillate as they absorb energy, and identify most common greenhouse gases. So the most common or the biggest change in climate are driven by increasing the greenhouse emission. Now we start the cycle with the solar radiation from the sun, and it's mainly visible light. Number three, on your homework, we want to identify what GWP is. GWP stands for Global Warming Potential, and the global warming potential measures how much heat will be trapped over time compared to the same amount of CO2. For example, CFC has the highest, CFC 12 has the highest over 20 years and 100 years compared to CO2. Number three actually asks for the the GWP of nitrous oxide is higher than methane, and it changes less over 20 years and 100 years. Why does the GWP of nitrous oxide change less, and why does methane have large total greenhouse forcing contribution? Now if we look here, I know there's a lot of numbers, but let's focus on here in the atmosphere. Nitrous oxide lasts over 100 years compared to methane, which is 10 years. And then another thing we want to look at is the concentration of methane is much higher than nitrous oxide. So nitrous oxide lasts longer, more than 100 years, but the concentration of methane is 6 times as high. Okay. Let's see, that was number 3 on your homework. Now, when a gas molecule observes electromagnetic radiation, the energy is converted into kinetic energy, and the motion gets more and more energetic. And there are 3 forms of motions: stretching, bending, and twisting. Now, of course, so converting kinetic energy, and then that energy keeps it in motion and it's more and more energetic. Of course, different molecules have different sizes and shapes, and they stretch at a different frequency. Stretch, bend, and twist at a different frequency. All gases absorb electromagnetic radiation at a specific frequency, but the greenhouse is the one that absorbs enough energy to keep the Earth's surface about 35 degrees warmer. So the greenhouse is the one that actually changes the temperature. Now you have this graph, which is water and carbon dioxide. Water vapor is the most powerful greenhouse gas. Water absorbs incoming sunlight as well as the outgoing infrared. But the ozone absorbs incoming UV radiation. So not only CO2, but also water vapor absorb some of these gases, greenhouse gases and infrared. I'm going to compare carbon dioxide to methane. Which one would have more absorption mode? Now, if we look at carbon, carbon dioxide is a carbon and 2 oxygen. Methane, though, is 1 carbon and 4 hydrogens. And methane has more absorption mode because it has more atoms. This one is 4 compared to 2. And also they have different angles. Now you also have this one in your text. It says incoming and outgoing radiation. And incoming starts with about 55% of the solar radiation actually reaches the Earth. The 45 sorry, 45% are UV, short waves, and visible light. The visible light is really not touched, but the UV and the short wavelength infrared are absorbed by the oxygen and the ozone. Now the 12% are just reflected back in the atmosphere. The outgoing radiations are long wavelength. Infrared are absorbed by the greenhouse gases. So incoming are short wavelength and visible. The one that's going out are infrared, and that's the ones that are being absorbed by the greenhouse gases. And oxygen and nitrogen make up the majority of the atmosphere. But eventually, because the greenhouse gases, CO2, it has a lot of motion. Once it strikes nitrogen or oxygen, it also absorbs that energy as well, and it becomes a greenhouse. It does the same effect. Okay, so this one, oops. We have CO2 with a lot of energy, infrared energy. So the vibrating molecules undergo a collision with the oxygen and nitrogen and transfer some of that energy of the infrared is absorbed. And it shares that greenhouse effect with the other oxygen and nitrogen, which is the majority of the atmosphere. Okay, so vibrating molecules can also emit infrared, but it emits it in a new direction, so it goes back to the surface, Earth's surface, so it's trapped in the atmosphere. It's not really given off. Only 10% it actually goes through back in the space. Energy is constantly arriving, so the sun keeps shining every day and giving off energy, and energy is released in the forms of infrared radiation. The Earth's surface temperature is determined by the amount of outgoing infrared energy that's absorbed by the greenhouse. So this is what being measured, the amount of infrared outgoing and absorbed by CO2. It's kind of a cycle. Every day, more and more sun coming in, converted into infrared and being trapped in the atmosphere. Okay, so to summarize, increasing the concentration of infrared absorbing greenhouse gases will increase the amount of energy trapped in the atmosphere and decreases the amount of energy escaping the atmosphere, resulting in higher temperature. Okay, and this is the sun, and then the CO2 gaining infrared, more collision, colliding with other gases, and all of these gases keep reflecting back to the surface, not really going into space, but they keep trapping the heat or infrared back in the surface. Okay, and that's that. Thank you.